In this video, we will learn sets of numbers. We know there are different types of numbers like complex numbers, real numbers, integers, rational numbers. So, we will learn those numbers. Now, in xy plane, this is x-axis and this is y-axis, and they meet at this point. This is origin O, and any number on this plane is called complex number. If you take any number here or here or here, any place, then that will be complex number. And if you take any number on this line from x prime to x, this is x-axis. That means if you take any number on the x-axis, then that would be the real numbers. So, what is the definition of real numbers? Real numbers is denoted by the R with double leg, and it is, you can write roughly as x, where x is from negative infinity to positive infinity. Okay, so this is real numbers. Real numbers. So, any numbers on this x-axis is real numbers. It is from negative infinity to positive infinity. Now, real numbers is first letter is R, that's why it is denoted by R with double leg. Now, complex number, so this is complex number is A plus IB form, where A and B is element of R. This is element sign. That means A and B are real numbers. Okay, member of real numbers. So, this is the complex number. Complex numbers. So, for complex number, this is first letter C, that's why it is denoted by C with double leg. Now, what is A plus IB and what is I? I is an imaginary unit and its value is square root of negative 1. The value of I is square root of negative 1. We will learn more. So, if you take any value, any point here, so you can represent this point as 1 unit here and 2 units up. So, this point is 1, 2, and you can write this one as z equals to 1 plus 2i. Okay, a complex number normally represented by z, and this one 1 and then 2i. So, here 1 and 2 is real numbers. This 1 and 2, A is 1 and B is 2 there. Now, if you think only, okay, one more thing. What is the relation between real number and complex number? What is the relation between real numbers and complex number? Did you see real numbers is on this plane? So, every real number is also a complex number. Every real numbers is also a complex number. For example, if you think 2, so 2 is a real number because it is on the x-axis. Now, 2 you can write as 2 plus 0 times I. Okay, so now it is in this form A plus IB, where A is 2 and B is 0. So, every real numbers are also complex number, but the converse is not true. That means every complex number is not real number. Now, if you think only this part, okay, now on the x-axis, this is 0, this is 1, 2, 3. So, if you go this way, positive x-axis, then it increases. If you go negative x-axis, it decreases. Now, there's another types of number, that is the integers. If you think these whole numbers are -3, -2, -1, 0, 1, 2, 3, that means -3, -2, -1, 0, 1, 2, 3, it's keep going. Okay, so those are whole numbers but both positive and negative. Okay, so those numbers are called integers. Integers. Now integers is denoted by z. Why? Because this z comes from the German word Zahlen. It's Zahlen. Okay, it comes from the German word Zahlen, and its mean is number. So integer are those number. Now if you think only this part from 0 to this way, only this part, then that is called whole numbers. That means non-negative integers. If you 0, then 1, 2, 3 and keeps going, so those numbers are non-negative integers, and it has a special name that is called whole numbers. Whole numbers, but these are non-negative integers. Non-negative integers, and its first letter is W. That's why it's denoted by W. So whole number is denoted by W. Now if you think only if you exclude 0 from here, so we will think only this number 1, 2, 3, 4, 5, 6, 7, 8, those number, then it is positive integers. Okay, it is positive integers, and it has a special name that is called natural numbers. So it's keep going. So that is natural numbers. Natural numbers, or you can say positive integers. So for natural number, first letter is N. That's why it is denoted by N with double leg. Now if you think only this part between 1 to 2, so now we will think only this part from 1 to 2. So I zoom out it, 1 and 2. So between 1 and 2, how many numbers exist between 1 and 2? So between 1 and 2, actually infinitely many numbers exist. So you can think this point is 1 over 2, sorry, 3 over 2, because it's 1.5. Between these two numbers, there is another number here. Between these two numbers, there is another number here. Okay, so this number is ratio of two integers, because 3 is integer, 2 is also integer, and this is ratio of two integers, and it has a special name that is called rational number. So next number is rational number, and it is denoted by Q, and it is this from M over N, where M and N both are integers, and this N cannot be 0. Why? Because if we divide, we cannot divide anything by 0, that's why n cannot be 0. So this is a ratio of two integers, that's why it is called rational number. Rational numbers. Now its first letter is R, but it is denoted by Q because already R is taken here. Now why it is denoted by Q? Because this is quotient. This is quotient of two integers. So this is quotient by two integers, that's why it denoted by Q. So now there is another types of number that is called irrational number. That means if you subtract the rational numbers from Q, that means if a number cannot express m over n form, where m, n are integers and n is not 0, then that is number is irrational number. Irrational numbers. For example, pi is an irrational number because we cannot represent it ratio of two integers. E is also irrational numbers, and the value of pi is it is 3.141593 approximately, and the value of E is 2.717282. Okay, so these digits are like never terminate or they never repeat the same pattern. Okay, for irrational number, those digits never terminate or never repeat the same pattern. Also, square root of 2 is irrational, square root of 3 is irrational, square root of 4 is not irrational. Why? Because if we take square root of 4, then we will get a integer. Okay, so 4 is a perfect square number and its square root is not irrational number. So next number is 5. So square root of 5 is irrational, square root of 6 is irrational, square root of 7, square root of 8. If we take square root of 9, then we will get an integer. So square root of 9 is not irrational number, but square root of 10 is irrational. So it will keep going. So you can think this way, that means if a number is not perfect square, then its square root is irrational. What does perfect square means? Perfect square means if you take square root of that number, suppose 4 is a perfect square number. 4 is a perfect square number. Why? Because if we take square root of 4, then we will get 2. Okay. Then 9 is also perfect square. Why? Because if we take square root of 9, then we will get 3. Okay. So what is the next perfect square number? 16, because if we take square root of 16, it is 4. So if a number is not perfect square, then its square root is irrational. Okay, that's it. Thanks for this. Thanks for watching.